my name is María. I'm working at Heriot-Watt University, and I'm going to show a demo related to a data predistorter that I did during my PhD. So, for those of you who don't know, data predistorter is used to linearize amplifiers, and in our case, the predistorter is related to the APSK constellations, and in particular, I'm going to show the 16 APSK, which is part of the DVB-2 standard for satellite communications. So before explaining the whole thing, I'm going to present the setup. So in here, in the laptop, we have the DVB-2 signal that we developed here in Heriot-Watt. Then this signal is transmitted to the signal generator that I have in here, right? That will transmit the signal to the power amplifier here. Then it's connected to the attenuator just to control the SNR or the fading. And then we record the signal with the spectrum analyzer here. So the screen of the spectrum analyzer is the same one that we have in here, so that you can see them more clearly. Okay, so this is the 16 APSK constellation. So basically, I send the signal, the DVB-2 signal from the laptop, and we can see here already what's recorded by the spectrum analyzer. And right now, the amplifier is working in linear region. That means that the 16 APSK, the standard that we have, you can see that clearly. So the inner ring is not that close to the outer ring, and everything seems that you can record your data and recover the bits in a good way. So what happens if I change the operating point of the power amplifier? So it will go from -20 to 10 dBm in here. You can see that now the inner ring got closer to the outer ring. That means that the bit error rate is going to be higher in this case. So our data predistorter is going to be related to change the distance between the two rings, so that when you are working in saturation, then they are not that close and you can improve the bit error rate. So I'm going to show, so let's go back to the -20 dBm, and I'm going to show a signal, the same signal, but in this case, I'm going to change the ratio between the two rings. So it's called the gamma. Having here, okay, and then setup. Yeah. So in this case, we're still working in the linear region, so it's -20 dBm, and now we change the ratio between the two rings, right? So let's see what happens when we increase the power again to 10 dBm. Yeah. So as you can see, in this situation, then the inner and the outer ring are basically in the same position as the standard 16 APSK. That means that you cannot confuse these two so easily as the case that we had before. So yeah, that's basically how our data predistorter works.